Hi, everybody. I'm David Barnett. I'm here to talk to you about what I found the secret sauce for coding with AI, which is smart testing. And I'm speaking in English, pero igual puedes preguntarme en español si quieres. Uh, my name is David. I'm a staff software engineer at a company called Quinto Andar. If you're familiar with Inmuebles 24, it's like the same parent company. And I used to work at Google, and I'm a reluctant AI adopter. Now getting along great with Claude Code, and Cursor, and sometimes even Gemini. So I want to talk about I don't know why there's little boxes on the emojis, but I want to talk about the problem probably a lot of you have had to do, like raise your hands. Do people here use AI, Gen AI daily in their work to get stuff done? Yeah. Does it always do what you want? Uh, any- anyone find themselves swearing at the AI? Oh. Yeah. So I do sometimes, and I'm no expert in any of this, but I've been able to spend some time kind of honing some skills and found a few tricks that work that I wanted to share. So what I found is when you're working on something with your AI agent, you'll get started. Things are going great at first. You're like 85% of the way to something really, really cool, and it's really impressing you. And then you drop off a cliff. So you're so close to something that's so brilliant, and trying to get that last 15%, you just go round and round in circles. And the problem with that is you don't have the expertise to to get the first 85%. You kind of got launched up that far, and you suddenly have to become an expert to dig yourself out of the hole that your friendly AI agent has put you in. So you're falling. And what do you do? Uh, there's no perfect solution, but I found that mixing in some smart testing strategies can really help to get you unstuck. So today I want to look at kind of the how that works, the hazards you run into, and then look at a few examples of things that have worked well for me, and have some time for questions. So let's meet the hazards. So you're starting on building something. You've all been there. You're giving it some prompts. The code is actually working. You're really impressed. It's exciting. Yeah, it works. Then you have everything working really nicely, and you start to kind of go into a routine, and your agent is suggesting edits. Okay, looks great. Accept edit. You're just clicking OK, putting it in auto run mode, and you're getting tons and tons of tests, and you're really hoping that they're good tests, because how can you look at all of them, right? But then the problem is you're only seeing from one level. You can't really can't really dig in and see that everything is structurally good with what it's building. You can, but it takes a lot of time and attention. So you've got all these tests that look okay. They're all passing. You're pretty sure that things are pretty much working. When you run it, it does pretty much the right thing. But more and more, you start to notice little cracks and weird bits of what it's doing. And then you hit some really big snag, and you're stuck. Something's broken. All the tests are passing. That looks great. But nothing's making sense. And the more you try to dig out and have the AI explain it to you, the weirder it gets. So for an example, sorry, the text is very tiny there. Um, so there was an example I ran into where here, I was setting something up with Claude Code. Things were looking weird, so I wanted to adjust some behavior, and I broke one of the tests. I made it so the test should not pass anymore. I broke the behavior it was testing, and then I was talking with it, and Claude Code was proudly declaring, "Great, all the tests are passing." And I said that was not the goal. That one of the tests is supposed to be failing. So there's one example. And then later on, here's a more extreme example. You might have seen this. Again, it's tiny, but there was I guess, a CEO, Jason Lemkin, who was apparently taking quite some liberties with the Replit agent connected to the production database. And he had specifically told it, we're in a freeze, don't do certain things. And it apparently deleted or corrupted the whole database and told him, no, we don't have any backups. And you specifically told me not to do this, but I did. So, and hid the error, lied about it. So it's obviously a giant mess. So the core issue here is AI, at least the Gen AI that we have in today's generation, kind of has a strong pull towards insanity. It's a little loco sometimes. And so a lot of it, is trained on what weird people on the internet have suggested. And the suggestions are not always great. So it's kind of absorbed the mindset of someone who's high on Reddit in a lot of ways. It'll do silly things like testing that that true is true, like that a value is equals what the value says it is, and just thousands of those. Sometimes you'll see a test is passing, but when you go look at the test, it's not testing your code. It's testing a copy paste of something that it made in your code. It doesn't mean anything that the test is passing. Or the test is kind of testing your code, except all the stuff that it's supposed to be verifying, it's swapped out for mocks that, again, don't really correspond to whether your code is working. And sometimes when a test does fail and you ask your friendly AI agent to fix it, you'll find that it just deletes the test and keeps the behavioral. So just put it in the trash. And kind of outside of the tests, when you're running your software, like sometimes some of the early signs you would have had that it made a call and something went wrong, or just that something broke, you'll find it broke a long time ago, but the AI helpfully made your code robust so it wouldn't break by ignoring all the failures that it encounters. So it'll suppress all the early error feedback you would have gotten to be able to debug. So what actually works to solve that problem? One thing is you really want a quick feedback loop, because the more rope you give your AI agent to do weird stuff, the further it's going to get before you realize it's gone off track. And a lot of times, the way the context works, it will kind of absorb the insanity, and even after you notice there's a problem, it's already gone so far off track, you have to just start a new conversation. So whatever you can do to get a good feedback loop can help. I'll show you something there in a second, but one thing you can do is if you have a test runner with like a watch mode, as far as I've seen, there aren't great ways right now to connect the like unit test watch modes to the agent so they notice immediately. But I find as I'm just watching myself, the magically updating test results, that it really helps me to immediately catch you've done something weird, stop and go back. So another thing I've been using just recently is whenever I start on a new branch, a new piece of code, then I will collaborate with the agent to make myself a little script, call it check this branch, and just capture some things like in these files, we shouldn't have comments like this, the certain tests it can check, maybe even formatting, but different kind of things to gauge, are we on track? And having this kind of focused output that the agent can check periodically really helps. Like I can approve that you're always allowed to run this script. You don't need to ask me. And then I can also check myself and get aligned with what signals it's paying attention to. Tell it, hey, you need to add some signals as we go. So I found that's very, very useful to get a very tight feedback loop. So like, here's an example. It's okay if you can't read Bash, but here's just looking for comments in the files that I know I'm going to be working on that say fix me, and reporting like, here are all the current comments that you should be paying attention to. So in my feedback loop, I can kind of just sprinkle little fix me comments around, and then as it's going, it guides the agent to the right parts of the code. And then another thing is when you're writing tests, even if they're pretty good tests, most people will reach pretty quickly for mock frameworks to say, like, expect a call to this dependency like this, return this result, and very specifically swap out the real behavior of the dependencies for a fake dependency. And that kind of works for a while. The problem is it makes very fragile tests. And if you have fragile tests, then you and the agent have to spend a lot of time updating the tests as you go, and you can't really get up to speed, like quickly changing the behavior, having the test still pass, and guiding you in the right direction. So I found that over mocking is a really bad habit, and one that especially the mindset that a lot of the AI agents seem to have absorbed from Redditors, I think. But you can teach them better. And here is an extreme example. You can see like, oh, I have a test. I have this like status. We're going to define active to be the string active, inactive to be the string inactive. And some people will find just pages and pages of test code like this that you can see add negative value, because that's never going to help you, and it's probably going to get in your way pretty soon. And this is a trivial example, but you can imagine more more interesting scenarios like that where the AI is just really testing the wrong thing. So another thing you can do is not so much is when a test fails, the way a lot of people will write tests, it will just kind of say, I failed. And then you want to know, why did the test fail? What do I need to do to fix it? And it's kind of hard to tell if it just says, oops, if it just says assertion error, expected success got failed. So a much better thing you can do is try to keep your checks and assertions in the test more high level, and say the result, the entire result should look like this. It should have these characteristics. And then if it doesn't, then you can see maybe it's a status failed, error message is XYZ or something, or status is success, currency is wrong. But you can much more quickly just look at the test failure, figure out, oh, this is the part of the code that's wrong, and fix it. And if the agent is doing that, then that's a really powerful weapon in your arsenal. So kind of similarly in like scripts that you have, shell scripts, or things like that, if you can both make sure that they fail obviously when something's wrong, so that you don't get too far after something gets weird before you see an error, that helps. Another thing that I found is really helpful is tracing kind of output. So instead of just seeing the like print messages and things like that, if you can put your scripts in a mode where they just step by step dump out what they're doing, what exact commands they executed, what values they used, then again the the agents can laser right to the problem that broke something. So here's a fun kind of visual thing. I was working on some documentation. I know it's weird. I'm a software engineer, but I wanted to write some documentation. And I was able to generate this really nice detailed bit of like ASCII box art. But if you look along the side, it looks really nasty. And I kind of didn't want it to send it for a pull request looking like that. So I've had times when I've just 10 times in a row asked Claude to fix something like that, and Claude will come up with all kinds of reasons. It used to be wrong. Here's what we're doing now. This should work, and then it looks exactly the same. Problem isn't fixed. So this time, I realized, why don't I have Claude help me to write a little checker to see are these things lining up. So that's what I did this time. And of course, I put that in my check this branch script. And then very tiny, you can see down here. It said, perfect, I've added a check which validates ASCII box art alignment. Let me test it. And then right away, it can figure out what kind of craziness it's doing that is making these things not line up. Because I think it's similar to the strawberry problem, where it used to be if you ask an AI how many R's are in strawberry, it would tell you 2, because it doesn't think in those terms. So when I would ask the AI to count how many spaces over it is, it would give me nonsense numbers. And so I had trouble fixing it until it could test with a script. And then like so I'm kind of jumping in between different contexts. I work in a lot of weird contexts. Another thing I was doing was working on a like bookmarklet, trying to do some stuff to kind of like fiddle with a website. And with that, it's pretty hard to get a good feedback loop because everything's running in the context of someone else's web page. And I had spent a while trying to fix some issues. I figured out that if I have the bookmarklet just do some diagnostics when it fails and dump out what expectations it's not seeing there, then I can just copy paste those back to my chat with the agent, and it can say, oh, we expected this, we got that, here's how to fix it. So then I got into a much quicker feedback loop with just kind of copy pasting errors and trying again. So those are some kind of different ways you can approach different parts of the development cycle. One thing you can do in addition to having like checker scripts to focus the agent on what you want, the results you want, is just capture notes about the purpose of the code you're writing. Capture to-dos, and a lot of like Claude will do this kind of automatically. Create a little Claude file, but I found if you really put a lot of energy into that and have it like try to update other documentation, things like that. There's a virtuous cycle where it'll kind of just make more and more connections about the code you're working in. So also, if you describe what kind of results you're looking for at the beginning of a project, it can do a pretty good job usually, because it's just working from your description. It can go find if somebody else had that same problem and dump out, a good bit of code that uh, pretty much solves your problem. But as you get further in the process, what you'll find is trying to combine the instructions you're giving it with the code that it has so far. It'll just get more and more confused. So one thing that works really well, instead of trying to describe, is show, don't tell. So if you are able to write 1, 2, 3 really good tests, and then say, make me more like this, then it can work from examples, and that goes much more smoothly. And then your most of the agents will have some kind of IDE integration. This one's kind of a no-brainer, but like make it enable that and set up like the linting and stuff so that the things that are annoying you are also annoying your agent and can be fixed right away. Um, so this is kind of a corner case I found, something that's kind of weird. If you tell like AI, don't use code like this, then it doesn't know if it's using code that's using code like that, if it's like transitively using it. So making the boundaries between like good code and bad code very clear, kind of marking what's deprecated, like moving things around, making them very well named, can also kind of get you a little boost. And for all those things, these are ideas. Uh, it's not a one-shot solution, so sometimes switching tactics is good. Like sometimes I'll get stuck and the responses from the AI aren't making sense. So I'll ask it like, what do you think we should do next? And just be very vague and kind of uh, use it, have a kind of weird dialogue with it. And sometimes that'll reveal some like kind of very deep misconceptions or something. But use it for where it excels. And then just kind of to restate the feedback loop. If you do set up some very very tight feedback, some good feedback signals, you teach it instead of trying to like just talk to the agent and show it the pattern. You can usually within reason set it loose, let it kind of work within that space for a while until it starts getting weird again, and then use those failures to steer what it's doing a lot more like unattended than you could do. And that's great because it saves you some time and energy. It goes faster, but also like things like background agents. If you can have multiple processes that you're kind of steering and it's just waiting on the AI to catch up, then you can parallelize those kinds of things if it's more hands off. So here's an example. Me writing tests that should fail. They fail, yay. AI makes a fix, test pass. Then updates the implementation, test still pass. That kind of flow really helps for fast iteration, immediate feedback. So without good tests, you're debugging mysterious errors, reviewing questionable code after it's kind of blown up. It's very frustrating. And you'll get kind of annoying responses usually from the AI kind of excusing why things are that way. But if you can mix in a little bit of strategic testing, then you can ship in days what it used to take weeks to do. You can make big refactoring. The AI is really good for like batch refactoring code bases as long as you have a foundation of good tests. Catch bugs before production, yay. And it works as kind of a force multiplier. And that's all of that, all the best strategies are no perfect solution. Uh, you still need to kind of calibrate yourself on how much rope you can give your AI agent of choice, and especially if you can set things up to really tightly catch problems really quickly as soon as they happen, then you'll get like 10 times the benefit a lot of the time versus like trying to reactively catch up. So early warning is huge. So secret sauce, not just use AI for everything. Definitely not just write more tests. It's not about quality, or it's not about quantity, it's about quality, but about being intentional with testing strategy and strategic about how and where to involve the AI. And that separates the developers who really struggle with using it from those who ship 10 times faster. That is all. Thank you.